Simplifying complex rational expressions. A complex rational expression is one in which we have a fraction. Here's the main fraction. And in the numerator and or denominator, there are other fractions. In this example, we have two fractions that are being subtracted. You might think that the simplest things to do is to combine them first, but actually a process that I like to teach is clearing denominators. So I'm going to focus on just the top of this fraction to start and look at the two denominators. And I wanted to decide what the least common denominator is between those two fractions. It's going to be x times y. So I'm going to use that least common denominator to clear the denominators. I'm going to multiply by both the same thing in the top and the bottom, the least common denominator. And if I do this correctly, those fraction, the y and the x in the denominator will go away. So let's start by multiplying this by the first fraction. That's going to be x squared y over y. The y's are going to cancel, so it's doing what I wanted it to do, and I just have x squared left over. So x squared is going to be sitting here. It's the main fraction. Let's move over and now multiply xy by this fraction. That is going to be x times y squared over x. Again, multiplying by that least common denominator, we were able to clear the x in the denominator, and we're left with a minus y squared. And then multiplying these denominators down here, we're going to get x times y squared. That's our final answer. You can see that we don't have a fraction in the numerator anymore. We could technically simplify this a little bit more. The top is a difference of squares, so we could write it as x plus y, x minus y over x y squared, but that doesn't really help us too much in this case. So either of these forms is fine. Let's look at example B. This is really complicated, much more than the first one. This is the main fraction bar. I have two fractions in the numerator that are being added, and then I have another fraction in the denominator. So I want to look at all three of the fractions, the two that are in the numerator, and this one in the denominator, and I want to find the least common denominator among all the denominators that I see. So it looks like my least common denominator will be c plus 2 times c plus 1. I'm going to multiply the main fraction by both the same thing in the top and the bottom, c plus 2 times c plus 1, which is my least common denominator. I'm going to multiply by the exact same thing in the numerator and the denominator. All right, let's focus on this being multiplied by this fraction first. When you multiply by a fraction, the object that's over here on the right is actually going to end up in the numerator. So it'll look like 2c, c plus 2, c plus 1 over c plus 2. And so what I'm really doing is I'm asking myself, what over here can cancel with that denominator? And it's the c plus 2. That c plus 1 is still left over. So after I multiply those two, I'm going to have 2c times c plus 1. All right, let's continue. And now let's do the same thing, but let's multiply this by this fraction. When I do that, I'll have c plus 1, c plus 2, or sorry, c minus 1 is the first thing. C plus 2 and c plus 1, and then divided by c plus 1. Again, I've chosen that common denominator because it'll cancel with that denominator there. And so we're left with c minus 1 times c plus 2. All right. Let's move on to our denominators now of the main fraction. We're multiplying this by this. And when I do so, this object should cancel with this one. and I'm left with 2c plus 1 times c plus 2. All right. One of the most common mistakes that students make at this time is that they'll see something that matches like this, and they'll go to cancel them. The reason we can't do that is because this is not just multiplication in the numerator. There's actually an addition sign there. So I can't cancel those. That would be illegal. So let's see if we can simplify this at all. Let's multiply the numerator out. I've got, let's see, 2c squared plus 2c. And then over here, I'll have c squared plus 2c minus c minus 2. I'll leave my denominator in factored form. Let's see, let me make sure I did this correctly. Let's combine like terms. We'll get 3c squared plus 3c minus 2. And it looks like that is our final answer.